everyone. Welcome to this edition of Aquarium Online Academy. My name is Stacy. I'm coming to you from the Aquarium of the Pacific in Long Beach, California. And today, or for this session, we are going to be talking about tide pools, a really amazing habitat. Now, if you have questions that you want to ask, or thoughts, ideas, observations, any of that you would like to share, I encourage you to send us a text. This is our text number right here, 562-286-1838. And if you text us, my friend Alicia is working on the computer over there to bring your questions to the screen here. And we can answer those questions during our program. And also share some of the observations that you made as well. Now, my friend Amanda is actually going to be bringing us lots of beautiful pictures, videos, all of that behind us. So we have a team of us working here today for this program. Now, again, we're going to be talking about tide pools. Now, tide pool is a habitat, and you might wonder what it actually is. Well, a tide pool is found along a rocky coast. So this is a very rocky coast, and most tide pools are found there because a tide pool is basically a pool of water that is left when the tide goes out. So we'll talk a little bit about tides in a moment, but the water level at the beach actually goes up high and it goes down low, and that changes a couple of times every day. So you get 2 high tides and 2 low tides basically every single day. And so when the tide goes out, when it recedes away from the shoreline, if there are little indentations, divots, holes, things like that, it can actually capture water. And that captured water is going to be really great for certain animals because it's kind of a tough life in a tide pool. So I think we actually have some footage of what that tide might look like coming in and then going out again. So we're going to bring that up. We're going to bring that up in just a moment so that way you can see what that kind of looks like. All right, and it takes just a few moments. So while we... So this again is just the rocky coast. This you can see. This is, I believe, up... Oh, well, it looks kind of close to here, but it looks like probably California for sure. And California really does have a lot of rocks all along the coast that make a really, really great place for tide pools to live, for tide pools to exist. But again, these tides, so the water level in the ocean actually changes. And that's all due to the gravity of, believe it or not, the moon and the sun. The moon has a little bit more impact on our tide because it's closer to us. Even though the sun is much bigger than the moon, so has a ton of gravity involved with it, because it's further, the pull on the tides is a little bit less. But the moon actually has quite a lot of gravity pull. And so depending on where the sun and the moon are located around the planet, it affects the water level. Now, take a look at this. This is fast forward. Time lapse per se. And you can see that the water level has changed, right? So right now, it's actually quite high. It was really close to where the camera was positioned. But when that video first started, the water was quite a ways out. Now, when it's far away, like at the very beginning of that video, when it was far away, we call that low tide. The water level is a little lower. And then throughout the day, it will go up and up and up and up, and eventually we call it a high tide, and that's the highest point. And then it will start to go back down again, and then you get another low tide. So as I was saying before, you get basically 2 high tides and 2 low tides every day. Now, it does change. Like, you can't say, oh, at 6 a.m. it's going to be like this. And that's because where the moon is located around us changes throughout the day. It doesn't go in a perfect circle around our planet. Have you ever noticed and you look up in the sky in the daytime and the moon is out? And then sometimes, though, when you look at night, the moon is out, right? So that just goes to show that the moon, the way the moon orbits around the Earth, is not consistent every single day, okay? So that's why our tides actually do change. And then what is also really interesting is the moon isn't always at the same distance from the Earth. And the Earth isn't always the same distance from the sun. So those distances change. So that means the amount of gravity pull is going to change as well. So sometimes our low tides are really, really, really low. And sometimes our high tides are really, really, really high. And so because of where we are relative to the moon and the sun, that's going to dictate what our tides look like. Pretty crazy, right? Okay, so tide pools, again, are pools of water that are caught when the tide goes out, when you get low tide. So it's an interesting habitat because there's a lot of change that happens. Sometimes the animals are going to be completely underwater. That's during a high tide. Sometimes they're going to be completely out of water during a low tide. And sometimes, if you look like right here, they're actually going to be hit by waves. And the change of the tide doesn't happen in an instant. It happens over hours. And so they could be hit by these waves for kind of a long time, just getting a little bit bashed by a wave. So all of the animals and algae that live in a tide pool have to have adaptations that help them survive this really dynamic, changing environment, this really interesting, challenging habitat. Now, we already have a few questions coming in, so thank you so much for sending us those questions. Mrs. Richardson's third grade class is asking, what do tide pool animals eat? And that's a great question. And the answer is it depends on the animal. So you can have a food chain or even a food web within a tide pool. So the animals can actually eat each other or eat the algae that is all there. They can also catch things that are coming in the waves. Maybe it's plankton that's floating around in the water. Maybe it's someone's leftovers that kind of got shredded in the water and they're able to capture that too. So that's more or less what things eat in the tide pool. It's whatever is available. All right. And then we have what would happen if two tides if the moon did not exist? They would be incredibly different. Now, again, the tides are affected by the sun. So there is some gravitational pull of the sun that affects the tides as well. But the moon does the majority of that work. So without the moon, our tides would look very different. And that also means the ocean and the land around that ocean. And actually, everything on Earth is interconnected. So things I think on Earth would be incredibly different if we did not have our moon. Or if we had more than one moon, right? There's some planets with more than one moon. Okay, so here is an example of some of the animals that you might find in a tide pool. Now, these animals here, you kind of can notice just by the way that things are moving, that they're completely underwater. This is actually one of the exhibits we have here at the Aquarium of the Pacific. And there are things like sea anemones and sea stars that are living in this exhibit. Now, sometimes the animals actually do fairly well out of the water. Sometimes they don't. It depends on the species of animals. So when you find sea anemones that might look kind of like this, you're going to find these types of sea anemones much deeper in the water. So they are really going to be in the deeper pools in the tide pools, or maybe just on the edge of the tide pool where they'd only be exposed if it's a really, really low tide. Whereas these sea stars that you see here, these are ochre stars. These kinds of sea stars have adaptations that can allow them to actually be out of the water for a few hours. And so those sea stars, you're going to notice them in the deeper areas, but even in the shallow areas where they are out of the water. And being out of the water, they can hold on to some water so that way they can breathe and survive, but they can't just be completely exposed to the sun because it gets incredibly hot. Most of the time when you find those types of sea stars, you're going to find them on a shadier side of a rock, or maybe even tucked into cracks and crevices. So they're kind of finding a little bit of shade. That's actually what I do during really, really hot days. I'm always the one who goes and looks for the shade. So I guess I kind of like behave like a sea star when it's out of water. But they usually have to get positioned before the water goes away, because once that water's out, if they move, they actually lose the water in their body, just kind of the way that their body works. Their movement of their feet that walks them around is powered by water. And so they're going to need to have water over them in order to be able to move. So when water's over them, they can move to a more ideal place. And as the water leaves, they can just hang out. All right. We have another question here from Jenna. Is there a mid-tide? There kind of is. So there is the low tide, right, when the water's totally out, and the high tide when the water's totally in, and then it takes hours in between. So to get from here to here, it takes hours. And when it's like here, that would be kind of mid-tide, I suppose. We don't really call it that, or at least I haven't really called it that before, but I think that's a good name for it because it's right there in the middle. And we have Riley asking, how big does a tide pool get? That's a great question. That's kind of a tough question, actually. So tide pools can vary quite a lot. They can be so shallow, there's not much that can even live in it because it's so shallow. It can also be incredibly deep. So I don't know if there is a specific size to a pool that make it considered to be a tide pool. I think if it's kind of blocked off from just the normal flow of the ocean, that it would be considered a tide pool. And I've seen some pretty big ones before. And you're going to find different animals in those large pools than the ones that are in the smaller pools. Okay, so we've talked a little bit about what the tide pools are like. We've seen a couple of videos of what kind of it looks like, right? So then what are some of the challenges that these animals have to face? Well, we mentioned either being completely out of water, completely in water, or even getting hit by waves. So that is a challenge. Another challenge is the sun. So if you're an ocean animal, you rely on the ocean water, and your body is adapted to ocean water. So if you were completely exposed and there was no water there, and there's the sun can be very, very hot, number one, and it can also dry things. Have you ever noticed, like if you were to take a small bowl of water and you put it out in the sun, the water level decreases? And it's because the heat of the sun is making the water evaporate or kind of basically turn into a gas and get absorbed up into the air. And that's what happens at tide pools as well. So that water can get evaporated away and then it's completely dry, just like the picture that you see here. So that's another challenge. So we have heat, we have being totally dry. Even the salt in the pools can change because if you have salt in water and some of the water evaporates away, it leaves more salt, less water. Okay, so that's a challenge too. So even kind of what the water's made of is challenging too. So again, a very tough place to live, but the animals that do live there thrive there. They do a really amazing job because they have the adaptations or things that help them survive right? So here's a couple of different animals. Let's focus on these ones. What do you notice about this animal? It is an animal, first of all. Does it look like an animal? To me, it kind of looks like a rock. All right, so they kind of look like rocks, but they are animals. And then if you look, oh, here's a great view of it right here. Look at that. It has like a little door. So this little door, when they don't have any water, they can close that door. And then on the inside of this little volcano, they can hold the moisture that they need to survive for potentially hours. Now, this volcano that you see here is actually very, very hard. And it's almost like having a little shell that is built around itself. This is called a barnacle. And so this barnacle has this like shell home, okay, like a volcano that has a door that it can close and it can hold on to all the moisture. And also being able to do that, it kind of protects it from the sun because you can see the sun hitting these ones right here and maybe a little bit of the heat as well. These animals can be found on the higher places on the beach. So they're one of the first animals to actually lose water when the tide goes low. So it's kind of interesting because that means that this shell is perfect for keeping them protected even when they don't have water. Now, when they do have water, when the water is flowing all around them, they actually like this water movement. And that's because they don't move. They're not walkers. And so when they're stuck to a rock like this is basically where they live for their entire life. They're like cemented to the rock. So how they eat, though, is they open that little trap door and their feet come out. They look almost like feathers, and they can capture the food that's floating around in the water to bring back in to eat. So they need the water to move around them so it can bring them nice, delicious food for them to capture. Now, these barnacles are actually relatives of crabs, and we have Isaac asking, are there crabs in the tide pool? These are relatives of crabs. They are arthropods, so they have kind of like jointy legs in a way. And here is a giant spider crab. This is definitely not in a tide pool, but it is a great example of a crab. There are crabs that look similar to that giant spider crab and this crab here that live in tide pools. Now, the ones that live in tide pools tend to be a little bit lower to the ground, a little bit more wide across this way. And the benefit of that is they can hunker down a little bit more, so when the wave hits them, they don't just go flying and break a leg. So they're a little bit lower to the ground. They tend to be smaller. I think the biggest one I've seen is probably about this big or so. And another thing they're really great at, and another reason why they're low to the ground, is they can hide in a rock crevice. So when the waves come crashing through, they're under the rock crevice. They can kind of hunker down and hold on so they don't just get swept out to the ocean. So yes, there are crabs. The crabs that I think of most frequently are shore crabs. And that's the little ones that hunker down that I was telling you about. There's also hermit crabs that you'll find in the ocean as well, or in the tide pools as well. And hermit crabs are little crabs that have shells on their back. The shells come from a snail, so a snail such as this one here. So when the snail is no longer living inside the shell, the hermit crab can actually put it on its back, and that's great protection from the sun. Right? So a lot of hermit crabs are also found a little bit higher up in the tide pool. They can live without water for a little bit longer. Now they do need water because that's what they use to breathe, but they can have shallower pools. They don't need the really deep pools that like a fish might need. So Isaac, thanks for that question about crabs. What happens if the tide pool gets too high? So the tide pool, if you have a really, really high tide, it actually doesn't typically affect the tide pool too much. Tide pools do okay having water around them. But I think the hard part is everything that's on the coastline. Like maybe there are buildings, houses, parking lots, people that are hanging out right along the coastline. And when we have really, really high tides, they're called king tides, sometimes you can get flooding. And especially if we have a really, really high tide and there's a big storm, then you can get a lot of flooding. So that's kind of where the really high tides can be a bit of a problem. It's actually more for the people than it is for the animals. We have Dalen asking, what is the largest tide pool animal? Ooh, good question. I'm going to look at my friends here. An octopus. Yeah, that's what I'm thinking too. I think an octopus might be the biggest tide pool animal. And it's not even a huge animal, but they can squeeze into tight places and they can walk around. And if they really need to, they can even walk from one pool to the next pool to the next pool. And that's really great because if your pool is shrinking or if it's getting too hot, it can actually just walk on the rocks to get to the next pool over. And here's a really good example of a local octopus called a two-spot octopus that we actually do see occasionally in tide pools in Southern California. I believe there's also some sharks sometimes that are found in tide pools, not in Southern California, but in tide pools in other parts of the world. And those sharks are smaller sharks. They can be maybe like 2 or 3 feet long. And those ones can, just like an octopus in a way, and this is kind of crazy, they can kind of go from one pool to the other pool. They use their fins to kind of push themselves over rocks and coral and things. So it's a really interesting adaptation to have to be able to jump from one pool to the next. Okay, here's another cool animal that you're going to find in a tide pool, but this one needs to stay in the water. If this animal is stranded where it's dry, it's not going to survive. This is a slug. It's really cool. It's a slug basically, and just like slugs on land, they need that moisture or their bodies will dry out. So this brown sea hare is going to be found in the deeper pools in a tide pool, and sometimes they're actually a little bit tough to find because their camouflage is so good. All right, we have a few more questions here. Where are tide pools most common? Great question. On the rocky shores. So here is a really good example of what that rocky shore looks like. Now, we actually have quite a lot of them here in Southern California. In fact, locally, you can actually visit a lot of tide pools. Now, they are protected, so if you do go visit them, just make sure that you don't take anything from there. Those animals are protected. They need to stay there. But the other thing, too, if you were to visit a tide pool, is that you really need to know a little bit about a tide pool to safely visit because you're dealing with waves, with rocks and seaweed and water, and it can be very, very slippery. So if you do visit a tide pool, I recommend that you read up a little bit on it to see how you can most safely visit. You make sure that you're with people who are kind of responsible. So if you're a kiddo, make sure you bring an adult. Adults, make sure you have other adults. And then you want to make sure that you watch your step because there's a lot of seaweed that actually covers the rocks and makes them very slick. Not only is it not good for us to step on because it's so slippery, you can slip and actually hurt yourself pretty bad. But also there might be animals hiding in the seaweed trying to stay away from that sun and trying to stay a little bit damp. And so stepping on the seaweed is actually really bad for those critters as well. So in Southern California, there is, let's see, I'm thinking about Dana Point. Let's see, Crystal Cove in Newport Beach has great tide pools. Palos Verdes has great tide pools like Abalone Cove. Let's see. Oh, up in Malibu, there is Leo Carrillo, and that's another really interesting tide pool. Not all tide pools look like this. This is a rocky tide pool. A lot of tide pools are rocky, but you also get some tide pools that are a little bit more sandy. And then, of course, they don't all look just like this, and they don't all exist around here. You also get some tide pools in the tropics as well. So you can have warm water tide pools too. So they kind of exist all around the world. All right. Let's see. Sephi asked, how do fish breathe underwater? Well, fish. Oh, here's a really neat tropical tide pool. Do you see this? So we're in the tropics. It's not near us. The water is nice and warm. But look at this. You can see there's pools of water all along the shore. So that's how we know that this is a tide pool. All right, so a tropical tide pool. Okay, so let's take a look at fish. So fish breathe using gills. And usually when you look at a fish, you can't really see the part that does all the work of being able to breathe. You see just a flap that covers it. And so that flap is called an operculum, and it protects the gills. Underneath that flap, here we go. So this is the flap right here. Okay, underneath this flap is the part, the actual gill. And when the water goes past that gill, it's basically made to take the oxygen out of the water and put the carbon dioxide into it. So it's just the way that our lungs work. When we breathe in, we're breathing in air. Your lungs are taking the oxygen out of that air because that's what we need to survive. We make something called carbon dioxide, CO2. We don't want that in our body, not too much of it. So our lungs are made to put that carbon dioxide back in the air, and then when you breathe out, you get rid of that carbon dioxide. It's the same thing with a fish's gill. The gill is made to take the oxygen out of the water, put the carbon dioxide into the water, and then the water goes out into the ocean. So that is how gills work. Okay, we have Miss Kim's class asking, how does trash and pollution affect tide pools? Great question. Think about the tide pools that we've been exploring. Okay, so we've seen lots of videos, lots of pictures of these different tide pools. What if there was pollution in there? What if there's trash in there? What do you think would happen? Well, it might be much tougher for those animals to survive. Maybe they would get caught up in something, maybe injured. And these pools are quite small sometimes. So if there's even just a little bit of chemical in that pool, it can be enough to maybe really affect the animals that are in there. So pollution and trash, those sorts of things can have a really, really negative effect on a tide pool because you're talking about such small parts of water. Plus, they live in such a difficult place anyways, right? All these animals, this life is hard. So it's kind of a high stress environment. If you add more stress to it, it might be so much that maybe they can get super sick or maybe not even survive. So pollution and trash is a big problem for tide pools, especially because they are so close to people. Being right along the coast, they are subject to having more pollution and trash around them. So thank you for that question. Okay, we have Sephi and Hadley asking, oh, they noticed a fish. Yes, I think you noticed a fish a while back. Sorry, I missed that one. When we were looking at the video, there was definitely a fish that swam through. And yes, there are fish in tide pools too. Do you think they would live high up or low down? I think low down, right? Fish need that water in order to breathe with their gills, just like we were discussing before. So they're going to need to stay with the water. You're going to find fish in deeper pools closer to the ocean, okay? Whereas further away, that's where we're going to find those barnacles because they have that hard shell that protects them. Okay, Allison, do you see sharks in a tide pool? We actually talked about that, right? Yes, you can. Here in Southern California, we don't see sharks in our tide pools. I believe the sharks you typically find in tide pools are found in the tropical tide pools. But fish. Okay, Ms. Bailey's second grade class. What is the most abundant animal in our tide pools? Ooh, good question. Well, there are a couple of different animals that are quite abundant. The barnacles, for one, are incredibly abundant because they do so well, right? That hard shell really helps them survive. Now, I think we actually have a picture that is that has mussels and barnacles, or barnacles and mussels, and mussels also do a really great job living in a tide pool. So these are the mussels that I'm talking about. These mussels actually have two shells and they close up like this, and the soft part of the animal is on the inside of the shell. Now, they do really well in a tide pool as well because of their adaptations. That hard shell and being able to close helps them keep water in their body so they can survive. The other thing that is amazing for them is that they can really secure themselves to rocks too. So if you can see here, there's actually a lot of rock. So you see the rock here, there's some rock over here, and they have these really special threads that they create that kind of hold them down to the rock, and those threads are incredibly strong. And so when the waves come and crash on them, they can still stay attached to that rock because of those threads. Now, all around the mussels, so the mussels are these ones, kind of the dark ones with the blue and the brown and the black. Look at these ones. To me, they almost look like they have scales, right? Those are another kind of barnacle called a gooseneck barnacle. And they, in some ways, are kind of like between a mussel and the volcano-shaped barnacle that we were talking about before. They have the legs of the volcano-shaped barnacle that help them to capture food, but they secure themselves to rocks kind of usually among all of the mussels here. So these mussels can be very abundant. You can have a ton of them. In fact, there are some tide pools that are almost overrun by mussels. So many mussels that you're not going to find gooseneck barnacles. You're not going to find a lot of other animals that need those rocks to hold on to. And that's where sea stars actually come into play. Sea stars are incredibly important animals. When